Hey guys, welcome back to TechGuides TV. Today, I'll be going over the TypeScript tutorial. Alright, so a lot of my students have been asking about TypeScript, if I could teach it to them. Maybe you're coming from a JavaScript background and you want to learn TypeScript, I highly recommend it. If you know, you know, TypeScript is such a useful type superset of JavaScript. It allows us to have custom types added on to JavaScript. Why is this important? Because it helps to write better code that is clearer. We know the types of different properties and variables. Let's take a look at this first bit of code here. Const user is, we have a user object with a name Hayes and an ID 0. So this is plain old JavaScript, right? It doesn't have any sort of typing. So we don't know if name is going to be a string all the time, or if ID is going to be like a true or false, or could name be a number, could it be an ID? So these are the type of problems that TypeScript tries to solve. In that second bit of code, you see an interface being created for the user, where the types of the properties are defined. So name is always going to be a string. ID is always going to be a number. If it's not, then it's going to throw an error. And this helps with this type checking helps prevent a lot of errors and bugs in our code. All right, so JavaScript doesn't come with typing out of the box, so we need TypeScript to be able to assign types to our properties, right? And it's TypeScript if you see the colon and then the type declaration there. So that third bit of code, const user, that colon after user, the variable name, tells you what the type is. It's a user type, right? So what's a user type? It's an object that has two properties, a name, which is a string, and an ID, which is a number, right? That's what TypeScript defines through the interface in that second bit of code. So user is defined by the user interface. Then it's assigned with to the user variable there in the third bit of code using the colon and the name of the type, right? And this helps prevent a lot of type-related errors in JavaScript. So that's sort of the best intro I could think of for TypeScript for you guys. Let's look a little bit closer at interfaces, that second bit of code, all right? So interfaces are at the core of TypeScript. We define interfaces to create these sort of unique custom types. So a user object, for example, you open your curly braces, you define sort of what the type of the name property is going to be. It's always going to be a string, all right? If we get a name property that's a Boolean or a number or a float, right, then it's gonna throw an error, right? And this is how we check for the right type of data being fed into our functions and the right data types, right? So the ID property is always going to be a number. If we get an ID that's not a number, it happens to be a string, that could cause a lot of problems in the code. So we need to do that type checking, and the interface allows us to create that custom type, the user type, right? And then using the classes in TypeScript and the constructors, we can assign parameter types and return types, and the sky's the limit with TypeScript, and it just makes your JavaScript code better. So I would highly recommend you learn TypeScript alongside JavaScript. Right, guys, so in the next slide, we're gonna look at interfaces alongside classes, what that looks like. So interfaces with classes. So we have the user interface defined there. It's gonna have a name property that's a string and an ID property that's a number. And then we have a class called user account with name and ID and a constructor function, right? The constructor function is invoked to create objects utilizing that class using the new keyword. So that last line of code, that's an object being created, a user object of type user defined by the interface being created. So const user of type user is equal to new user account, and the parameters we give it are Murphy, 1. So the name and ID of this new user, Murphy with ID 1. Let's say we have we're using this bit of code to add new employees to the company database. So we have a new hire named Murphy, and his employee number is 1. So we can use the user account class with the user interface predefined, and we can create a new user account for Murphy, the new hire, for example. Now, if we accidentally did a typo and we made the 1, instead of it being a number, we spelled out like ONE, and it was actually a type string, that could throw off the whole code. So that's why type checking is important. So we have that interface in place, so we know that we need name to be a string, ID to be a number always, otherwise our code could break. So that's the beauty of using TypeScript, using interfaces, classes, and doing object-oriented programming and all that. So moving on, we're going to next, what can we cover next? Let's see, how about, parameters and return types. All right, guys, these two functions look similar, but they're using types in two different ways. So in that first function, remember, if you see colon after a variable name, that's the TypeScript part. So the colon user means that the parameter that the delete user function expects has to be user type, which we define with the interface, the user interface. That second function, get admin user, you'll notice that the colon comes after the name of the function, get admin user, open parentheses, close parentheses, colon. That signifies the return type of this function. When we run the get admin user function, it's going to return a user object. Now, hopefully that makes sense. And yeah, so those are two use cases of our interface. Like, we can use it to notify what the parameter type is expected to be, or what the return type is expected to be. And this helps you write clear, concise code that is maintainable. A year later, if you come back to your code base, you'll know, okay, so the delete user function expects a user type, right? The get admin user returns a user type. Okay, so that's why TypeScript is really important, especially in larger code bases. Okay, so we've gone over the interface keyword in TypeScript ad nauseum at this point, but let's take a look at the type keyword. Why not? So the type keyword is another way of creating complex types. You'll notice the window states type is sort of a composite type, a complex type. It uses the OR operator there to create a type, a union type composed of one or more separate types. So a window states type is either open or closed or minimized, right? The lock states type, which we define with the type keyword there, is either locked or unlocked. All right, if it's either locked or unlocked, that statement is going to return true. If either open, closed, or minimized returns true. Remember, with the OR statements, you just need one part of that to return true for the type checking to work. So Windows states type requires one of those to be true, right? So the OR operator using the type keyword allows us to create these union types, these more complex types that are composed of two or more types. And then the type positive odd numbers under 10. It's exactly what it sounds like. Positive odd numbers under 10. So 1 or 3 or 5 or 7 or 9. If you pick any of those, if that's, let's say, one of those are the parameters in our function, it'll return true. It won't throw an error. because that's the type we expect in that function for whatever reason. Maybe it's a mathematical function that multiplies odd numbers only, so you need a positive odd number under 10. If it's over 10, the code would throw errors, so we do type checking. We use the type keyword, define our type, a union type in this example. And that's the difference between interface and type. I hope that's clear for you guys. Let's discuss unions a bit more in depth. So as I mentioned, unions are complex types composed of 2 or more separate types. All right, so for something to be of type lock states, it has to be either locked type or unlocked type. All right, and then it's that or operator is going to tell you that, all right, this is a union type. All right, so let's take a look at the getLength function here. So the getLength function expects an object parameter, and the colon right after obj there is the TypeScript bit where we assign the type to the input parameter. If we didn't have that part, it would just be plain old JavaScript. Okay, and we could accidentally pass in a number and the code would throw an error, right? So I'm really drilling down for you guys sort of the why of TypeScript. We need TypeScript, we need type checking to avoid code errors and to keep track of our code and our variables and functions, return types, parameter types, especially in large code bases. Okay, so and remember that's a parameter type. It's not necessarily a return type, but the return type is going to be object.length. So the return type would be a number, right? The length of the array. Okay, and the union type is composed of the object parameter being either a string or a string array. If it's either a string or a string array, then the union type it returns true. So it's a Boolean function. So that's where we would use unions in TypeScript. All right, and this is the final slide we'll go over for today's TypeScript tutorial. This is another important construct in TypeScript, this idea of generics, where it's used heavily with arrays. You know it's a generic if you can spot the angle brackets, right? The opening and closing angle brackets. So array of strings, right? Like an array of numbers is defined with a generic like that. So type string array strictly enforces that all the elements of the array are strings. Otherwise, it fails the type check, right? If there's a Boolean in there or a number in there, then it's not a string array, right? So that's a generic syntax. So array of type string, an array of type number means that it's a number array. All the elements inside of the array are expected to be numbers, and we designate that to avoid errors in our code. Okay, because maybe the function that accepts the number array parameter as a parameter can only work with numbers, right? You can't multiply strings, for example. It would throw an error. So that's why we would need to do a type check. Okay, this is a number array. It's not a string array, right? You can't necessarily, I don't know. I guess with operator overloading, you could add strings together, but typically we add, multiply, subtract, divide numbers. Whereas maybe we could if it's string concatenation, or maybe we're underlining or capitalizing all the words in the string array, we would need type string array. All right, guys, so hopefully that made sense. This was a TypeScript tutorial. I hope you guys enjoyed it. Subscribe to TechGuides TV for more tutorials like this. And if you enjoyed today's short course, definitely subscribe, leave a like, and I'll see you next time.